So first off, unless you're in the wrong room, we're going to be talking about push-button deployments using the Red Hat management stack. But before we get there, who are we, right? So my name is Mike Dahlgren. I'm a senior cloud solution architect for Red Hat. I'm based up in Minneapolis, Minnesota, mostly for the weather, but also because I get the opportunity to be here today. I'm joined with Laurent.
I'm Laurent Domb. I'm a cloud solution architect as well out of the Northeast.
And Maxim, Burgerhout, senior solution architect for platform and cloud from the Amsterdam office, and that has nothing to do with the weather in Amsterdam, I can tell you that.
So why are we here? I always like to ask this question, or more importantly, why are you here? What's the value of being for this talk? And really, why do you care at all? And what are we trying to solve? Because if we can't figure out what we're trying to solve, what does it matter what we're doing? So once we define those things, it's really about what is Red Hat doing to help facilitate this? And so if you think about it, there's millions of open source projects upstream, and Red Hat takes its arms around and kind of encompasses and cultures and fixes and works with them to build out about 40-some solutions based around those million open source projects. That's what Red Hat does. The thing is, they're all trying to do different things, and they're all different end goals in mind. So today we're going to talk about 4 of them. We're talking about Ansible Tower, CloudForms, Satellite 6, and Red Hat Insights, and really about how those things work together. So the first half of the talk, Laurent's going to be talking about what those pieces are and how those things can fit together to solve real problems. The second half, we're going to be talking with Max, who's going to go show actual examples of these things in use, and he even has follow-up videos on YouTube to show some more additional information on different ways we can work with these different tools. So with that said, why are we here? I always like to back up and make this as simple and this clear point as possible, and I think what we're really doing is talking about ideas. We're all here trying to get something done. And so we're trying to get this idea and we're trying to make something happen with it. And everything we're going to do today is going to be in that gray line saying, how do I go from a concept to production, right? How do I make something happen with all this? And when it comes from the Red Hat standpoint, what are these ideas? It's really, in IT world, it's about code. And I don't care what buzzword you use. Are we talking Internet of Things and digital data, defined data centers, or, I don't know, infrastructure as code? I mean, you pick your favorite buzzword. We love to do the same thing where we say, this code is a thing, this is an idea. But the hard part is we have to put it in production. Because if it's not in production, there's no value to it. And you break it out, and I think of it as the what, the where, and the how. So I love the what. I work at Red Hat. We got a lot of cool things. Hopefully you guys have seen a lot of neat things today, right? A lot of neat new code and solutions out there. But I'm also coming from an operations standpoint. I love the where. I love the servers. I like the new stuff that's coming out. I like all the physical bits. But we need to focus on the how, because the how is where 75% of IT spending is today. This is literally trillions of dollars is spent trying to move from one side of this line to the other. So I don't remember who told me this, but I really wish I could, and I think it's fantastic. He said the very worst day in a large company's life is the day that they buy a large piece of software. Think about that. The very worst day possible. Because what happens is day one, and you buy something, and you have no value from that thing, right? Code by itself doesn't do anything. It just sits there. It's shelfware. It sits in a box. But it's only when we operationalize it, when we put it into production, where we can actually bring business value out of that thing, does the company expand? Is it good for the company? And so this whole conversation is going to be how do we make that happen? Well, part of it's good tooling, but more importantly, it's about automation. Because what automation does is it brings the what and the where closer together. If I don't have to manually do this stuff by hand, if I don't have to push all the buttons, I don't have to worry about the how as much because I've compressed the whole conversation. And so what we're going to do today is really talk about how do the Red Hat tools fit together to enable single one-button push to solve these problems using the Red Hat management toolset. Sound good? Awesome. We'll take it away, Laurent. Thank you.
Okay. So what does it mean, to have one button push or being one button push away from Red Hat management, right? What it really means is you can pretty much have the entire Red Hat management portfolio fully integrated with around 3 hours, within around 3 hours. So, how do you do that? It's essentially pretty simple. So you take Satellite 6, which is our lifecycle management tool, which manages your RPMs, which manages, for example, Puppet modules. You can go promote those things via lifecycle environments. You can build hosts, even hosts in AWS, and everything which I'm showing you today is in AWS, actually. then once you have that piece which manages all your Red Hat content, you need something which is cross-platform and can view your entire infrastructure. CloudForms is our cross-platform cloud management platform, which can see everything you have from an instance perspective in AWS, in Google Compute, in Azure. When we look a little bit at the traditional infrastructure with Red Hat virtualization, SCVMM, and VMware, and if you're using more modern pieces like OpenStack and OpenShift, you're going to see that as well. So you have the full view, you have the management for your data hosts. Then you take Ansible Tower, very nice orchestration language across really your entire environment, right? And you can manage it. You take Insights, which looks at your infrastructure. Now, if you have all those four pieces, right, you need to shape them a little bit, and then you're pretty much almost done with it, right? Would be nice if it's, that easy, but it almost is. So let's talk a little bit about the pre-requirements to build this. Like from last year's talk, people came up to me and asked, how can we build the Red Hat management portfolio in an easy way? So I said, okay, let's do this year. So you have the GitHub repository there. You can download all the code. Essentially, you need at least Ansible 2.2.1. You're going to need an Ansible license. You can get a trial license, and this is going to get uploaded during the install. The same for the Satellite 6 manifest. Of course, AWS account you need as well, where you have enough credentials. And I also wrote an Ansible playbook, which uploads the CloudForms image, converts it into an AMI once it's there. So you have the entire solution. And also remember, we're using Ansible Vault files for this, for the passwords, private keys, etc., because we're not saving passwords in Git. So that's a very important thing there as well. So once you have all this, you can go a step further. And when we said button push deployment, we really meant button push deployment. And I'm going to show you with that enter button what actually happens. So we have a master playbook for Ansible, which starts building the entire stack. And I'm adding my private key so that Ansible afterwards can log into that AWS instance which gets created. The password vault file is to decrypt the vault so that Ansible has all the passwords. So then we have Ansible Core starts building, and Ansible Core builds Ansible Tower. Right? So Ansible builds Ansible Tower. It's kind of cool. When you look at that from that perspective, let's see what happens. So Ansible goes and starts up from the EC2 module, builds an instance in EC2. You have a wait module in Ansible which says, hey, I'm going to wait until that instance is up. Once that instance is up, I'm going to go SSH into it. That's really what you see here on the screen. And then it starts building Ansible Tower. Now, Ansible Tower is fairly easy to build because per se it gets built via Ansible anyway. But if you begin to do cross-integration, it's a little bit more challenging. For example, if you have SSL communication, afterwards we're going to see between CloudForms and Ansible Tower, you need to exchange certs somehow. And Ansible is very good in being able to delegate certain tasks to others or being able to do certain things, and we're going to talk about that as well. What you see here on the screen as well, it's a little bit small, but the third line from the bottom, which says settings pie. So Ansible Tower has this security mechanism called Burgerhout, which basically makes sure that no one, when he executes something from Ansible Tower, is able to read files on that actual Ansible Tower node. Now, if you need to exchange certs, you need to know what you have. So you need to basically enable that, and this is what you can do in there. There were also some other enhancements which I have to do to make it work. They're all in the GitHub repo as well. But once it's up and running, you're going to see that screen. Now, you realize there are already numbers there and some playbooks, and the reason for that is because I really wanted to make sure that everything is already done for you. So all the credentials for AWS are already created in Ansible Tower. You're going to have the inventory already for AWS there. The jobs to create Satellite 6 and CloudForms did already start, so I'm creating the shell there. And you have the full-blown management piece. So it's really like a very good tool from an Ansible point of view to manage cross-platform your instances there, and also go, as I did, into AWS and use the modules there as well. So since the version 3.1, we have also tooling which enables you to easily create orchestration workflows. And you could technically do the same thing I did, not with the orchestration workflows, with the workflows in the Tower UI as well. So you can chain playbooks, you can define when an inventory needs to be synced, when something fails, you can define what happens, and it's really kind of a point-and-click solution which you can start. So that's very, very nice. So, anyone knows who this guy is? Yes? Who is it? Aquaman. Why did I choose Aquaman for Ansible Tower? What are his strengths? No one, yeah? So Aquaman is really good in the water, right? But he's also good when he gets out of the water. He has super strength. When you look at Ansible and Ansible Tower, Ansible really came from the server management point of view, right? And it really took over the networking world and the storage world. So it's really like going into both worlds. So there's some similarity with Aquaman, like being able to really perform in the water, get out of the water and perform that as well. So now we have Ansible Tower up and running, and we're going to see now what happens next. Next, Ansible Tower automatically, so remember you just launched the button, and that's all you did. It's now executing an Ansible Tower job to build CloudForms in AWS. Now, CloudForms per se, the setup process is not that complicated, but if you need to automate it, it's a little bit challenging. So essentially what happens there is when you build CloudForms in AWS, the AMI is already there because we uploaded it. It starts up the appliance, and now we need to create a database, which is created automatically in the script. All the roles for CloudForms are going to be enabled. For example, get CU data, etc. Host names are already done. And what we also need to do, and this is where the challenges came in with CA certs, I need the cert from Ansible Tower in CloudForms so that I can add the provider for Ansible Tower in CloudForms automatically. Because we have cross-integration there natively, but it's per default via API SSL, and so I had to do that. Now, the interesting thing about it, when we go to the next slide, is that once it's up, I can do all the integration, and I also added, like, not just Ansible Tower, but it's cross-functional. And we're going to see that. So Ansible Tower is going to have CloudForms inventory. CloudForms is going to know about Tower. It's going to have the AWS provider as well. So everyone knows about everyone from a tooling perspective. So let's look at this. So once basically I get to the hurdle of going to Ansible Tower, getting the cert and putting it into CloudForms, and from a technical point of view, for those who are interested, it was actually an interesting challenge. It's how do you get a cert you don't know to another host. And Ansible has this nice capability of registering, for example, a variable when you launch or execute an action against it. So I basically did it simple. I just catted the file, registered the output, delegated a task to CloudForms to create a new file with the output I had from the other one, and then imported it into the cert data store. So it's like Ansible really from a cross-platform and execution perspective is really, really awesome. So we have now the integration into Ansible Tower, and when we see what this actually gives me is the inventory which we have for AWS in CloudForms and the inventory for AWS in Tower, but also the CloudForms inventory in Tower. Now where's the benefit? The benefit is simple. The benefit is now I see everything which I have in Ansible Tower in CloudForms, and what that means is I can go to the templates in Tower now, and from CloudForms, and this is in CloudForms, I can go and say, create a service dialog from that specific Tower template, and make it available in, for example, the self-service UI for someone to consume. So this is pretty big from an integration point of view, because you can really execute those playbooks from a self-service catalog once created and auto-generated, which is pretty awesome. So we have Spider-Man here, and he says there, when you look at it, like if you use CloudForms and Ansible, you can build like anywhere at any time, whenever you want. And it's really the case because you have with CloudForms the view on everything you have, and you have with Ansible the tool which can reach everything you have. So same reason here, that's why I chose Spider-Man, because if you look at the web, right, and like he puts his spider web out, it connects all the points pretty much with each other, and that's what you have there with CloudForms and Ansible Tower as well. So if we go now to satellite, it's the same thing, tower now, and those jobs really run in parallel. So the CloudForms task and the satellite, they're on parallel. Satellite takes the longest, really, and the reason for that is because once we build satellite, we need to begin to do all the channel synchronization, we upload the manifests, etc. And when we look at the actual interaction, what happens now is we now get integration from satellite to CloudForms and from Ansible Tower to satellite. We also synchronize, as I said, the channels with like the CDN, so we have everything synchronized. And we have also integration into the AWS, like console there from a compute resource perspective, you actually see those resources as well. So in CloudForms now, after satellite is up and running, I delegate the task and say, now import that specific provider in satellite, now in CloudForms, which gives me from CloudForms now the ability to do bare metal deployments via satellite from CloudForms. And another capability I gain as well is that now I can actually call host groups from satellite, so if you're a Puppet user, for example, and then run basically those host groups against the specific host I'm building. So you have full integration between that stack. Then the satellite inventory also gets added to Tower. And remember, everything I'm showing you here is native integration, so it's not something we need to plug in and build new, that's there. So you have now also satellite, so you have the entire management solution there, and you can kick off like those Ansible runs, for example, against a satellite host you build with a callback after the kickstart to Ansible Tower executing something. So that's very nice from that perspective. Then what you gain as well with the integration of satellite and CloudForms is that you have now the tooling from a compliance perspective, and you have the data available. And you can also, for example, create a policy, and based off that policy, create an action which either, for example, satellite or CloudForms is going to go and remediate. You see down there, CloudForms with a button with the CVEs. This could also trigger, for example, an Ansible action, which goes and then remediates basically the issues which you see there. So if you have really CloudForms Satellite 6 and Ansible Tower, it really means at the end of the day that now you cannot just build anywhere you want at any time, but now you can also build a secure infrastructure and make sure that what you're actually having out there is patched and secure. So the last piece of the puzzle, when we look at that, is really this piece. So we need to phone home from an insights perspective. We're going to gather information about your hosts, and then from there, we get the information back if you can improve something within your environment. Red Hat Insights then goes back to Satellite 6 and CloudForms. These are the two tools which currently collect the insights data. And then what's pretty new and nice is you could also create, for example, Ansible playbooks, which naturally go and remediate automatically what you see there from an insights perspective. So insights is not just about security, it's also going to tell you about stability and performance, for example, and you see that here. So in this case, there's an issue with configuration of crash dump kernel parameter in Go. And essentially, it would show you, if you did drill a little bit deeper into it, how to fix it. Or from a performance perspective, an example here with Numa, which also shows you right away what you need to do to fix it. But for me, the nicest thing really is this slide, which shows that you can create a playbook out of what Insights tells you, okay, this is wrong, and you got to go and fix it. So, very, very powerful. So, we have Wonder Woman here. Why Wonder Woman?
Yeah, why?
So why Wonder Woman? Very simple, right? When you go home and let's say you have like a pile of clothes somewhere and you put them together somehow, not so nicely, and you put them in the closet, your wife comes home, she's always going to find it. You're always right. It's the same thing with Insights. It's like no matter what you do, if you think you can hide something, Insights is going to find it, right? So, and that's really like powerful from that point of view, because there are certain configurations you think you're doing right, And it's like you might have done it like at that day, but Insights really sees what you're doing, even from a configuration point of view, and can tell you if it's really right, and if it's not, you're going to get alerted, an email, whatever, that what you've done might have been wrong. So when we look at the superpowers team, right, essentially, when you have them fully integrated, and this is what you really get after that button push in about 3 hours, you have a framework which basically allows you to really deploy pretty much anywhere you want and manage that whole application set across the entire life cycle. And this is really what Maxim afterwards is going to show you with a multi-tier, multi-host deployment based on the infrastructure. I actually deployed in AWS, so used the same infrastructure to build what he was doing. So essentially, really, it means with everything, you can provision anywhere you want again. And you can really feel secure that once you have really a patched infrastructure, and on the other side, we're really watching you, that you're not, making stupid things. So I have a demo, but we don't have enough time to look at it. If you want to, here is the link which shows the entire deployment. It's also on GitHub, it's the same. But I'm going to pass on Maxim and Liz.
Ready for my 20 minutes of fame? So, Laurent is originally a really nice, gentle Swiss guy who has done all the work for you, basically. He's written all these playbooks to deploy Ansible Tower and Satellite and CloudForms. And I'm actually here to tell you to go do everything yourself, because I'm a blunt Dutchman and I'm just not so gentle. So, what I want to talk about is application deployment, because Laurent deployed the infrastructure that can help you manage your applications and deploy your applications, but we haven't talked about actual application deployments yet. So who's familiar with the N-tier paradigm, basically applications that are built according to the N-tier paradigm? That's only 5 people, so that's good that I have a dedicated slide about that. So when we talk about application modernization in Red Hat, we often talk about the big monolith applications that are then turned into N-tier applications that hopefully eventually end up as microservice applications somewhere in the future. The N-tier application is a bit of an intermediary step where we split the application up in different tiers. For example, load balancer tier, web tier, database tier, caching tier. So basically the application is composed out of different server roles. Now, traditionally, I've been in consulting for a while, and I'm pretty sure a lot of you have as well. Deploying applications like that have involved a lot of scripting, either through Bash or Perl or Python or whatever. You maybe predetermined public parameters that you had to pass. Always was kind of tricky to do, deploy the whole multi-tier application on multiple servers in one go. And that is where that combination of CloudForms, Satellite 6, and Ansible can really, really help you. And that is what I want to talk about in the remaining maybe 20 minutes of the session here. So I'm happy I have this. For the people that were not familiar with the concept of an N-tier application, this is what I'll be talking about for the remaining part. So we have a load balancer, we have 2 web servers in between, then we have a database as a database tier. So it's basically a 4-server application, okay? People falling asleep, it's not good. Maybe I should shout more. So how does this work? How can I build automation that does the whole deployment from nothing to a running application completely? So the first thing, I need something to create my servers. I need to create virtual machines somehow. Then I need something to configure the operating system in my new servers. And basically I need something to get the new and old and patches and errata and software from to install on those new servers. And then, and that's a really important one, I need something to tie everything together, because I want to teach the load balancer where my web servers are. And I need to teach the database from which web servers to allow connections. I need to tie everything together. And then finally, I want to have this special place, because automation is only half complete if you don't have this last part. I want to have a special place where my users can go to and press a big red button that says gimme, and that deploys their application completely from A to Z. So these are the five things I need to do to create that complete automation. In a Red Hat management portfolio, what we're talking about to create those virtual machines, it doesn't matter, it can be on Amazon, on Azure, on Hyper-V, on Rev, on VMware, it doesn't really matter. That's what CloudForms does. CloudForms creates the virtual machines for you according to a predetermined set of parameters. Then, to configure the operating system and install software from, we have Satellite 6. Laurent already talked about that a bit. And then to tie things together, and that's an extremely important part of this whole setup, is Ansible Tower. Because Ansible Tower is one of the best tools, I'm not afraid to say it that way. Load balancer, that is where your web servers live. That's the IP address that you need to balance the data, balance your load over. So, and then finally, the place where the big red button is, that's CloudForms again. So basically, that is the same couple of applications that Laurent has deployed for you, and now I'm going to talk about how to build your own automation in CloudForms, Satellite, and Ansible to deploy your own multi-tier application, because I'm sure even the people that didn't raise their hands, you have them. So how does it work? From, pictures, always good. So there's a user, and there's a self-service portal. The user goes to the self-service portal, and the only thing the user needs to do is enter a couple of fields, maybe a name for the application, maybe he needs to enter an SSH key, maybe he needs to tell CloudForms how big the virtual machines need to be. User goes to the self-service portal and presses the big red gimme button. And then CloudForms goes out to OpenStack, it says here, but it can also be any other virtualization platform, and creates virtual machines or instances in CloudForms. And then after that's done, CloudForms is going to pass control to Satellite and wait for the configuration through Puppet to finish, and potentially Errata to install. All the while Satellite is configuring, the Insights client that Laurent talked about before is being deployed and starts gathering data immediately. When that part is done, CloudForms is going to take control back and pass it to Ansible Tower. And tell Ansible Tower, these are the 4 virtual machines I've just deployed, now make the application work. And then finally, all the while this is happening, CloudForms keeps track of everything that is going on and will inform the user of the status of the deployment. And then finally, in the final step of the deployment, it will tell the user through email or whatever, your server is done, that's the URL to connect to, where your application is deployed. Now, in terms of CloudForms self-service items, because I'm going to create items in a self-service catalog, I'm going to create 2. I'm going to create a self-service item to deploy those 4 virtual machines, and I'm going to create a self-service item to deploy an application. And I'm going to do it that way because I might want to be able to reuse this. I might have more than one application that runs on this same 4 type of servers. So I'm going to create 2 self-service items. How hard is it to do that? Because I think that is important to know. It is actually, who has ever created or written or downloaded a heat template or a CloudFormation template for AWS? Only 2 people? So for the people that have never heard of heat templates or CloudFormation templates, or I don't know what the Azure equivalent is, but I'm sure they have one. It's a long JSON file that describes a deployment made up of instances, software-defined networking, security groups, everything that goes with the deployment of multiple interconnected virtual machines on a cloud, be it private or public. Those things are JSON, so it's fairly easy to read. There's a set structure for these things. You can download them all over the web. They're fairly easy to customize, but they're usually, for example, in OpenStack, they're used by storing them somewhere and then pasting them into some text field in a web UI. That is not nice. So what you can do is you can take those heat templates or CloudFormation templates and you can upload them to CloudForms. And CloudForms will keep them for you and make them available for self-service provisioning. Now, a CloudFormation or heat template can contain parameters that you have to pass to the deployment mechanism to, for example, insert a specific SSH key. From the orchestration template that I create from the heat template or CloudFormation template, I can create a self-service dialog. This is all automatic. I take the CloudFormation or heat template, I upload it. I only have to click the Create Service Dialog from Orchestration button, and CloudForms will create the form for me. CloudForms will create the form based on the parameters in the template that will allow the user that orders this specific catalog item to upload or specify his own SSH key or specific size of the instances that will be used for deployment. This is all automatic. When a self-service dialog has been created, you can obviously customize it. So you can, if you have to type in the whole name of the SSH key, you can create a little drop-down menu from that. But this is all automatic. This is fairly easy to do. This is not rocket science. So that's the deployment of the virtual machines. The Ansible part, Laurent already talked about that, is actually not that hard, not that much harder. In Ansible Tower, we have this concept of a survey. Who has used Ansible Tower and knows what a survey is? A survey is a little bit of a technical way of doing self-service through Ansible Tower that allows you to create a form a user has to fill in when the job is run. CloudForms consumes those surveys and creates a service dialog. So this part as well is not that complicated. You can import everything into CloudForms, and CloudForms will create the forms for you. You can customize the forms afterwards, but this part is all automatic. So now we have 2 self-service items. I have created a CloudFormation self-service item that deploys to 4 virtual machines. There's a little bit of cloud config script in there, by the way, to register the system to Satellite, but I'm not talking about that in too much detail. And then I have a self-service item to actually deploy the application on top of those 4 virtual machines I've just deployed. But that's nice, but this is only half the work. Because now I would have to order this, wait until it's done, take the names of the virtual machines, and order that to run on the 4 virtual machines I've just created. So it's not ideal. To be honest, it sucks. This calls for something we call a bundle. So basically a bundle allows us to take those 2 catalog items we talked about before and wrap a 3rd catalog item around it, which we call a bundle. And this, too, is not that complicated. CloudForms has a fairly simple dialog for that, and you can just select the catalog items you want to have deployed in order, and CloudForms will create a self-service item for this as well. You can probably for this one just reuse the service dialog you created for the CloudFormations one. So now I have a bundle, and now I have one thing that actually deploys the whole application with the software-defined networking and the virtual machines and everything around it as well. So I can almost hear you think, how hard is this and how does that work? So before I dive into how hard it is and how to actually make that work, I want to do a little bit of a detour into a concept in CloudForms that we call a state machine. Has somebody ever heard of the concept in CloudForms that we call a state machine? I'm happy about that because it allows me to explain. So, a state machine is the process inside of CloudForms that takes a request for either a couple of virtual machines or the run of an Ansible Tower job and processes that request until it's actually fulfilled. So what I try to compare it with is a production line. It's a production line that takes a request. There are all kinds of robots along the production line. The robots all have their specific task. For example, actually create the virtual machines or send an email that everything is done, reserve IP addresses. All those robots have their own specific task in the production line. The request goes in and the VMs come out. That is what a state machine does in a very simple explanation. So each of my catalog items that I talked about before, they have their own state machine. And the state machines we ship in CloudForms have a set of predefined steps. So we ship state machines that you can just reuse for all of your deployments. Most of the time, you don't have to do anything in customization, and the predefined steps we put in there are okay. But we leave a lot of placeholders where you can put your own robots to basically maybe call out to your CMDB, or maybe call out to Slack or HipChat if something goes wrong. So you can create your own robots along the production line to add extra automation during the creation of those 4 virtual machines in this case. Everybody still with me? Okay, cool. So the placeholders you can use to execute additional custom steps in this deployment. And why am I telling this? Because I needed to do this. And I want you to show a little bit of how that would work. So why did I do this? So I was bundling catalog items, right? And in one of the second catalog item basically is an Ansible Tower job run. And Ansible, as you all probably know, does a lot of stuff with Yum, right? It installs packages and it creates it changes configuration files. But that is the same thing Satellite does if I use Puppet, because Puppet also calls Yum. So I really wanted to make sure that the Puppet part in Satellite was done before I made the step to the second catalog item and the Ansible Tower job started running. Does that make sense? Now, CloudForms by default does not ask Satellite how is the configuration status of this virtual machine. So basically what I did is I took one of the placeholders and I put a custom method in there, and that's just a little bit of Ruby scripting. You can download it there, you can take a look, you can use it as a bit of getting started code. I'm not a developer, so the people in here that actually develop, that code probably sucks. But it can help as a little bit of a getting started guideline and help you just get working with writing those custom methods. This method, basically what it does is reach out to Satellite and check if all those 4 virtual machines exist. And if the virtual machines do not exist, we wait. If the 4 virtual machines all exist, we check what the configuration status is. If the configuration status is empty, we wait. If the configuration status is okay, the machine is configured and we can move on to the next step. So actually, it's relatively simple to do. And then we can actually only start the tower part when the satellite part is done, so they don't conflict with each other. The second part of customization I've done in here is that during the first part, I'm creating 4 virtual machines. In the second part, I want to limit the Ansible Tower job run only to those 4 virtual machines. So I have to pass the names of the 4 virtual machines to Ansible Tower. So in this script, there's a little bit, I store the 4 names of the 4 virtual machines in a variable, and in this script, we read the variable, we pass it to Ansible Tower to limit the run of Ansible to those 4 virtual machines. This is probably better code because this is just a little bit adapted from what we ship. I think I only changed 2 or 3 lines in there, so that should be fairly okay. But you can download it, and that way you can get started writing your own automation, because you probably will do, you probably might want to call out to your CMDB or something like that. We have a lot of customers that want to do a little bit of customization. So how hard is it to customize a state machine? It's probably the next question. Well, the state machine is just a table with rows, and each row represents a robot. So the production line is a table, each row in the table is a robot. A couple of those lines are empty, you can put your own robots in there, and you can store those tables, they're represented in YAML, you can store them in Git, you can just take hours, change them, and store them, and reuse them anytime you want. It's not that hard. If you want to know a little bit more about the background of writing your own automation, there's this awesome book by a guy from the UK, Peter McGowan, who wrote a pretty complete guide about writing your own automation, customizing state machines. And we actually give this away for free. You can go to the Red Hat website, you can download the book, and you get started writing your own automation in CloudForms basically overnight. I too had a demo, but yeah, I have like 6 minutes left. That's not going to fit. There's a little video on YouTube there. It takes 10 to 12 minutes. You can download the slides afterwards. And you can, I basically show how the WordPress deployment that I mentioned before, how that works from A to Z. I take you through the whole deployment with a little bit of commentary in the background, and it deploys that application on 4 virtual machines running on AWS based on the exact set of things that I've just explained. So let me know what you think about that, because I'm eager for feedback. If you don't think it's good, I want to hear that as well. Let us know what you think. Our email addresses are on the very first slide of the deck, so give us feedback. We'll also all 3 be manning the CloudForms booth along the way, so if you want to have a bit more of a discussion about this kind of thing during the summit, we're there. We'll be there on Wednesday, you were there on Thursday, I think, so come and see us. You want to make some final closing remarks? Then I think we have about 5 or 6 minutes left for potential questions, so if anybody wants to fire the first shots. Let's hear it. I usually have prizes to entice people to ask questions, but I'm from Europe, so I wasn't allowed to go. I didn't bring anything, let's be honest.
I would have a question.
Yes.
You know, when designing more complex services in CloudForms, you typically have like, you know, tens or hundreds of them. Do you find it really like practical to use each Ansible job call as a catalog item? You know, because from the code organization point of view, that's...
So this, what we call from CloudForms is not actually each Ansible task as a catalog item, it's a whole playbook. Yeah, so if you do the deployment over 100 virtual machines, you would probably have a playbook to run over those 100 virtual machines.
Yeah, sorry, I wanted to say it was playbook.
Yeah, so it's a playbook, yeah. So if I didn't make that clear enough, then apologies. Yeah.
No, just the question is, do you find it like practical, or what is the best practice? So, is it better?
Yes. So yeah, for those who maybe didn't hear the question, so he asked if it makes sense if you take, for example, you synchronize with Ansible Tower, you see all the playbooks you have. If you go and you generate basically a service dialog from every single playbook which you have within Ansible Tower. And the answer to that is we don't do that, right? So essentially when you build the playbook, you're gonna have a master playbook which calls your roles on whatever you want to integrate. So the same way as when he built his WordPress application or I built the entire management suite, I have a master playbook which calls other playbooks then afterwards for doing something. The flexibility you get by being able to choose certain pieces is that you can kind of put them together the way on how you build your playbooks if they are dynamic. So you have the choice there on how you kind of would do it, but you probably, or you're not really going in and create a service catalog item for every single playbook you have.
Any more questions?
Oh, come on.
just to clear. So
Bar won't open any earlier, I believe.
No, it's good. And if you have any questions, I mean, if not, you have the email addresses, which were on the first slide and were at the CloudForms booths. But if not, thank you very much.
Yeah, thank you.